applications. So, for whatever reason, we sort of switched from calling things word problems to calling them applications. Maybe because students got so, I don't know, I don't like word problems, I'm scared of word problems. Like, oh, it's not a word problem, it's an application. It's the same thing. Call it whatever you want. Rational equations is what we were just doing. So, ratio, fractions, we know what equations are. That means we're solving. So, it's solving the same kind of things we were just doing, but we're going to start with a word problem to set up the problem. The only formula for today, although we're going to tweak it a little bit, is distance equals rate times time. I'm guessing you've seen that formula before? Yes or no? Some no's, some yeses. Okay. Maybe in science, sometimes in math. Maybe we should back up a second. Distance equals rate times time. Let's do an easier problem then. Let's say you drive, we'll be on the highway here, 60 miles per hour for 2 hours. Right, 120 miles. Like some of it you just kind of know. Let's show the work though. Distance equals rate times time. Rate is how fast you're going. So velocity, speed, rate, how fast you're going. So we're going 60. I'm going to show the units on this. You guys are in chemistry. You understand how a lot of times units, you can get the right answer without really knowing what's going on as long as the units work out. 60 miles per hour. That's how I survived college chemistry anyway. Like, I don't understand, but I can make the units work. So 60 miles per hour times 2 hours. Well, 60 times 2 is 120. That part's easy. What happens to the hours? They cancel. And so what units am I left with? Miles. And so my distance would be 120 miles. So distance equals rate times time. If you go 60 miles an hour for 2 hours, you've traveled 120 miles. We're not going to do anything that easy, but that's kind of the building block that we start from for distance equals rate times time. We're going to start putting things together where we're going to travel two distances. Like maybe we'll drive somewhere and drive back. Or if you look down at the example problem, the speed of the wind is 20 miles per hour. So, and we're going to do a round trip. So that means part of the trip will be flying into the wind, and part of the trip will be flying with the wind. So there would be two distances to travel. Well, distance 1 is rate 1 times time 1. Distance 2 is rate 2 times time 2. So it's always distance equals rate times time. It'll just be rearranging things, putting things together. Let's see, solve for R. So if I want to solve for R, what would R equal? V over T. Divide both sides by T, distance over time. So if we sort of rearrange the problem we were looking at earlier, if I traveled 120 miles in 2 hours, that would be 60 miles per hour. And if we wanted to add rates, well, rate is d over t, so d1 over t1 plus d2 over t2. This is not like 14 different formulas to remember. There is one formula to remember, and then we just use it a bunch of different ways. Same kind of thing for time. If we divide both sides by r, distance divided by rate, then time 1 plus time 2 is d1 over r1, because that's time 1, plus d2 over r2. And in some ways I don't like writing all these equations down. It makes students think, oh my gosh, there's 1, 2, 3, 4, 5, 6 equations to know. Like, no, there's not 6 equations to know. There's 1 equation to know. And we can rearrange it however we need to. So this is the big deal. Everything else comes from that. So distance equals rate times time, and then arrange it how you need to. Okay, guided practice. I guess we're giving credit to the textbook here. Distance equals rate times time. That's the equation we need to know. We'll rearrange and do with that what we need. Okay, the speed of the wind is 20 miles per hour. It takes a plane 7 hours to fly 2368 miles, 2,368 miles, round trip. Round trip, so like there and back. Determine the plane's speed in still air. Okay, distance equals rate times time. But there's sort of two things going on here. Like there's part A of the trip and part B of the trip. I'm just going to try to draw this out before I go to equations. We don't know which way the wind is blowing, so I think we're just going to have to pick one and make our equations from there. So, do you want to go with the wind on the way, or do you want to go with the wind on the way back? It doesn't matter. On the way back. Okay. So that means our wind is going to be blowing this way. So that means on the way there, we're fighting the wind. On the way back, we get the wind. This is the way to do it if you're going to run somewhere out and back. Like you want to fight the wind first and then have the wind help you on the way back. It doesn't matter, though. So how fast the plane goes, that's what we're looking for. Let's call that R. That we don't know. Okay. So if we're fighting the wind, the plane goes R miles per hour in still air, but the wind is blowing against us. What would the expression be for our speed, for our rate? Do you know? Like the plane can go R miles per hour on its own. If we're fighting the wind, R minus 20. Like normally it's 100 miles an hour, but into the wind, now it's only 80 miles an hour. How about the trip back? What's our speed going back? R plus 20. Now we get the wind, so we'll go faster. Let's see. What else do we know? Tell me. The total distance, okay. Total distance is 2368. Should be careful here. That's like the total distance. That's exactly what you said. And the total time is 7 hours. Is the distance for each path half of 2368? Yeah? Yeah, because like the cities didn't move, like they're fixed. Is the time 3.5 for each? No, that's where some people get mixed up. They're like, oh, it's there and back, so 3.5 hours each way. You're like, no, it's slower getting there and faster getting back. So, let's see. Our total time is 7 hours. This distance, the distance for both of them is half of 2368. Let's see. We'd probably have a calculator for this. 1184. So that distance is 1184. The second distance, not the second distance, it's like the same distance. Also 1184. And the total time is 7. But again, the two times are different. So let's say that T1 plus T2 equals 7. T, what's distance equals rate times time. So what's T equal to? Well, the total t is 7. What about my equation? Sorry, I didn't ask that very well. Just forget all that. If I solve this equation for t, what do I get? D over r. So that means T1 is D1 over R1. T2 is D2 over R2. And those two times add up to 7. All right, so what is D1? What is our, maybe I should have done A and B because that's how I labeled them over here. D1 is, or DA is 1184. In fact, while we're thinking about it, may as well fill that in for the other one. Both distances are 1184. What is the rate on the way? How fast are we moving on part A of our trip? R minus 20. And how fast are we moving on the second leg of our trip? R plus 20. And so now we've got an equation with just one variable in it. Man, that took a little bit to set up. Most of these setup problems are going to have a part A and a part B. That's going to be kind of the key, is figuring out the part A and part B. Okay, we get here. Let's see. That looks like the things we were working on the last couple days. So this one needs an R plus 20. This one needs an R minus 20. And then this 7 needs both of them. Alright, this is going to need a calculator here pretty quick. What am I going to do next? The next step is the good step. Yeah, multiply by the denominators. So this is the step that looks awful, but it's in preparation of the step that looks great. 1184 R plus 20 plus 1184 R minus 20 equals 7 times R plus 20 R minus 20. And pretty soon I'm going to need to grab a calculator. And pretty soon is probably now, right? So grab a calculator, I'll hit pause and grab a calculator. Really paying attention, I might notice that 1184 times 20 minus 1184 times 20 is going to go away. But most of the time I don't notice that until I write it all the way out. And I'm like, oh look, they cancel out. That's a difference of squares, so I don't need a calculator for that. The middle terms will go away. 20 times 20 is 400. Let's see. We said those would cancel. There's our 2368. We add those back together again. It's a quadratic. So let's move everything over. Get it equal to 0. I have no idea if that factors. I don't really want to figure out if it factors. There's one thing I could do that might make life easier. Like 7 is divisible by 7. 2800 is divisible by 7. If 2368 is divisible by 7, then this will make life a little easier. Fingers crossed? Oh, it's not. Okay, well, so, if you don't want to factor it, and I don't want to factor it because I don't even know if it will factor, what's my other option? Quadratic formula. I've got a calculator. The numbers are big, but that's okay. X equals, or I guess in this case R equals negative b, have to sing slow this time, plus or minus the square root of b squared. Well, you got a calculator, so no big deal. V squared minus 4AC. You got a calculator, don't complain. All over 2A. It sounds like I'm in pain singing. Is that? Okay. Let's see. I think maybe I do the inside stuff first. 2368 squared. I'm just going to, like, some of you guys mess up your signs. It'd be better if you understood the signs and didn't have to worry about the calculator doing it. Like, I skipped over one. If I square negative 2368, that's the same as squaring positive 2368. So rather than mess up the signs, like some of you are going to type this into your calculator, why is that not right? That's going to give me a negative, but that's not right. I need to square the negative, or better yet, understand what's happening and just take care of the negative on your own. Speaking of negatives, two negatives make a positive, so I'm going to handle that on my own and just say plus 4 times 7 times 2800. That's a lovely number.
Wait, negative. Yeah.
I didn't put negative in a couple places because I know what's going on. I know if I square a negative, I'm going to get a positive, so I'm not worried about it. And I know that two negatives make a positive, so I'm just going to go ahead and put plus. If that messes with you, then you better do it carefully and put in negative 2368 squared minus 4 times 7 times negative 2800. That should be the same thing. But if you understand math, you can go a little bit quicker in the calculator. Okay. Big numbers, fractions. Oh, I'm gonna use the fraction bar. Get all fancy here. 2368 plus or minus, so I don't know which one to use first, plus square root, and then you can go up and like copy that all over 14. Okay, so there's one R. Remember, we only get two answers here. R equals 339.46. I hope that's raising alarm bells in your head, but we'll talk about it in a minute. Then let's do the other one, the minus sign. I can go grab that whole expression there and then just go change the plus to a minus. So copying and pasting is easy if you know how. All you do is go up there and hit enter.
So you just select the area and then enter?
Correct. You just go grab whatever you want to grab. It can be an answer or it can be an expression, and it'll put it where you want it. All right, so my other R is negative 1.178. So, well, it's not distance, it's R, it's rate. So, R was the speed of my plane. So either my speed of my plane is 339 miles per hour or negative 1 miles per hour. Which one do you think seems more right for a plane? I think 339. I don't think going backwards 1 mile an hour is going to accomplish anything here. So that would be an extraneous solution. The math got us there, but in the context of the problem, that doesn't make sense. That happens when we do quadratics. Okay, so there was a lot of stuff going on in that problem. Literally zoom out here for a minute. Distance equals rate times time. That was the basis of the whole thing. I had to think about two different directions there, almost two different legs of the flight, two different pieces of the flight, and put all the pieces together. And then I had to solve an equation, a rational equation, which led to a quadratic equation, which led to a quadratic formula. It's like, man, can you do all of those things without messing up? And this is where, we say this all the time in math, it builds and builds and builds. So if you don't know the quadratic formula, you're cooked. If you don't know how to do a rational equation, you're cooked. If you didn't know distance equals rate times time, you got to be able to put it all together. you're cooked. But you know all those things, so you'll be okay. I mean, maybe not right now, but eventually, like, we'll get there. Working together, it took Anthony and Travis 6 hours to mow the lawns of all their clients together last week. The previous week, it took 10 hours to do it by himself. How long will it take Anthony if he wants to mow by himself? Excuse me. Thank you. Okay, well, this doesn't really look like a distance equals rate times time problem, right? Because there's no distance. But there is time, and there's kind of a rate, like how fast Anthony works and how fast Travis works is a rate. So we're going to just tweak the distance equals rate times time formula. And it's kind of the same thing. It's the job equals rate times time. Okay, so let's think about this. So the job is it's one job, right? The job is mowing all the lawns. That's the one job. Working together, this looks like it's going to be one of those pieces thing, like the plane was there and back. This is not a there and back problem, but we got an Anthony's equation, we got a Travis equation, and we got a together equation, or information. So together, time was 6. The previous week it took Travis, so Travis's time was 10. How long will it take Anthony if he mows by himself? So that's what we don't know, is how long will it take Anthony to do this job? Let's write a Travis equation, because we know Travis is 10. So job equals rate times time. Job equals rate times time. One job, right? He didn't do all the loans twice. Occasionally we get tricky and do that kind of thing. But one job. We don't know his rate, like how fast he mows, but we do know it took him 10 hours. I'm going to put a subscript on that R because that's Travis's rate, not Anthony's rate. Oh, I think I just learned something here. What's Travis's rate? 1/10. Let's see. Let's write the Anthony equation. 1 equals R Anthony times time. Nope, I don't like that one because I don't know his rate and I don't know his time. Maybe we should write the together equation. One job equals. Okay, here's the key step of this. They're working together. So it's sort of like when you're flying with the wind is helping you, you add the rates. Here they're working together. So we can say Anthony's rate and Travis's rate. They're working together. That equals 6. Okay, I got equations all over the place. I know RT is 1/10, so I can plug that in. How about RA? What's RA equal to? I mean, just as an equation, I don't know the answer, but 1/T. So I can plug that in for RA. So let's take this equation. So 1 equals RA. Oh, sorry. There's RA plus RT, which is 1/10, and 6 hours. Well, there's an equation. We're ready. We can solve that. The setup is the hard, as with all word problems, right? Like once you get it set up, then it's not too bad. It's the setup that's the tricky part. What do you want to do first to solve for t? There's a couple options. Probably distributing the 6, probably the easiest thing to do. 6 over t plus 6 over 10. Okay, now we know why it's in this section, because that's a rational equation. So let's make all our denominators match. 10t, 10t, 10 and 10, t and t. Whoops. Okay, again, pausing, making sure my denominators match. 10t, 10t, 10t. Favorite step, multiplying by 10t. 10t equals 60 plus 6t. So 4t equals 60, t equals 15. Let's see, does that make sense? Takes Travis 10 hours, takes Anthony 15 hours. They work together, takes them 6 hours. That seems reasonable enough. All right, again, the setup on these is the tricky part. Let's try another one. This one's pretty similar. Noah and Owen build birdhouses together. If Noah can build a particular house, so that's like the one job thing, that's the job. In 6 days, there's a time. And Owen can build the same house in 5 days. How long would it take to work them together? So let's kind of list out our information and see what we know here. Let's see. Noah can do one job in 6 days. Owen can do it in 5 days. Together we don't know. That's what we're looking for. Do you think, can you get a guess on if they're working together? Will it be in between 5 and 6? Will it be less than 5? Will it be more than 6? Less than 5, right? I mean, if Owen can do it together, if Owen can solo the project and get it done in 5 days, if he has any help at all, it should be less than 5 days. So I should get an answer less than 5. We'll see. Okay, so the Noah equation is one job equals rate times time. So Noah's rate is 1/6. Same type of thing for Owen. Owen's rate is 1/5. And now the together equation. How many jobs are they doing? One. Like they're doing one job. They're not building 2 houses or 5 houses. They're doing one job. What's their rate if they're working together?
1/6 plus 1/5.
Good. They're gonna work together. So 1/6 plus 1/5, and then time, we don't know how long it's going to take. That's what we're looking for. Their total time, together time. Let's see. So with a calculator, I'd probably solve this differently than if I was doing it by hand. Let's do it by hand. That matches what we've been doing, and then I'll show you the calculator way. So distribute the t. What's my common denominator going to be? 30. So that guy needs a 6, that guy needs a 5, that guy needs both. Great. This is the old news part of the problem. multiply everybody by 30. Everyone's favorite part of the problem, because that wipes out our denominators. So 30 equals 5t plus 6t. So 11t equals 30. 30 over 11, but like this is a word problem. I want to know what that is. Like how long is it going to take him to do this? 30 over 11 is not really the answer I'm looking for. Uh-oh. Man, I got a calculator that's dead. 30 divided by 11. Somebody typing in?
2.7272.
Okay, 2.72 days. That makes sense. We knew it would be less than 5. So 2.72 seems reasonable. We really want to think reasonable. What if they could both do the project in 5 days? So separate problem, but if Noah could do it in 5 days and Owen could do it in 5 days, do you know how long it would take them working together? 2.5. That's why we don't give you those problems, because those are easy. You just, they work together, they cut their time in half. This is not quite half of 5 because Noah's a little bit slower. So, thanks for helping, Noah. Wish you could speed up a little bit, but it's still better than flying solo. So the next page is the assignment, but I think we should probably do a few more of these together. That's okay. That's why we landed this one on a block day. At the top, distance equals rate times time, or job equals rate times time. Okay, define the variable, set up an equation, solve algebraically. That's what we've been doing. Show your work, label your answers. Got it. Pump A can unload the Lunar Petro in 30 hours, and Pump B can unload it in 24 hours. Because of an approaching storm, both pumps were used. How long did they take to empty the ship? Okay, so is this a distance equals rate times time problem or a job equals rate times time problem? A job. They've got a job to do. They need to empty the ship because of this storm. Okay, they were nice enough to just call them A and B. A, B together. So I think this is pretty similar to that last problem we just did. Right? Instead of birdhouses, though, we're unloading a unloading a ship here. Okay, pump A takes 30 hours. Pump B takes 24. So together, what do you think? More than 30? Between 24 and 30? Less than 24? Less than 24. Less than 12? More than 12. Let's get real specific here. Good, more than 12. But probably less than 15, right? Because if it was 2 pump A's, it'd take 15. So I'm pretty sure I know my answer is going to be between 12 and 15. Okay, let's write the pump A equation. So one job equals rate times 30. So rate A is 1/30. Rate B is 1/24. So together, they're still doing one job. They're emptying the ship once. They're not emptying it twice or halfway, just one job. What's their combined rate? 1/30 plus 1/24. And the time we don't know. That's what we're looking for. Okay, so I'm going to press pause and let you do the algebra from there. Although we're pretty sure we're going to get something between 12 and again, with the calculator, and you didn't want to think as hard as Ava thought to get to the 120, you could do the 30 and the 24. And it would look like that, and it looks terrible, but I should get the same thing. 720 equals 54t, divided by 54. So yeah, You don't have to get the least common denominator. It just makes your life a little easier. You just need any common denominator, especially if you have a calculator. All right, 2 is a little different. The county's new asphalt paving machine can surface 1K of highway in 10 hours. A much older machine can surface 1K of highway in 18 hours. Yeah, that's not very good. How long will it take them to surface 21 kilometers of highway if they start at opposite ends and work day and night? Okay, so we got a new one, an old one, and a together one. So let's see what we know. This is more of a distance problem, because you could say the job is 1K, but this is why the problem, or why we like to phrase it this way. If you say the job is 1K or the distance is 1K, it's the same thing. It's the same formula either way. But you can definitely think of this one as a distance equals rate times time. So the new guy is 1K in 10 hours. So let's write that equation. So 1 equals rate times 10. The old guy is 1K 18 hours. I should be careful. That's not the same R, so I should probably not write that like that. I should probably put a subscript on there. You can call them A and B, you can call them 1 and 2, you can call them old and new, but call them something so you don't get the R's confused. What about the together equation? What's the distance we're going to go? 21 is the distance. The rate, what am I going to use for the rate? Oh, I skipped over something here. Yeah, I need to combine the rates. So 1 over 10, 1 over 18. Because they're working together, so we're going to add their rates.
Do they have to split the money?
Well, I think they all belong to the county, so it's all good. Let's see. I don't know that I can come up with an answer like we tried to figure it out ahead of time, because they're not going 1 kilometer, they're going 21 kilometers. So I don't know what my answer is going to be here. All right, Ava, you got a least common denominator, or do we just want to chicken out and go 10 and 18 and not worry about it? Yeah, that's fine. Like 10 and 18 is the easy way to go. They both have a 2 in there, so I guess you could land at 90. But again, if you got a calculator, it's probably easiest to just say, I don't need a least common denominator, I just need a common denominator. So we'll use 18 and 10. Again, without a calculator, I'd probably slow this down and be a little bit more careful, but with the calculator, I don't mind working with big numbers, because I'm not doing it, the calculator's doing it. $37.80 equals 18t plus 10t. $135 hours. That seems like a big number, but it took one machine 10 hours to do 1 kilometer, so if we're going to do 21 kilometers, yeah, it's going to take a lot longer time. So I think I believe that. Start backing off and letting you do some of these, but let's try number 3. Sharon drove for part of a 150 kilometer trip. So this is definitely a distance equals rate times time. At 45 kilometers per hour, and the rest of the trip at 60 kilometers per hour. How far did she travel at each speed? Oh, that's kind of two questions there. How far did she travel at each speed? So I got to give two answers here. The first distance and the second distance. If the entire trip took 2 hours and 40 minutes. Okay, well, I don't like 2 hours and 40 minutes to start with. How can I change that to just hours? What's 40 minutes? 2/3. Careful. 2/3. 40 out of 60. So 2 2/3. If you use 2.67, then you should probably use more than 6.7. Then it's like to get an accurate answer. So 2.666, whatever. 2 2/3 is probably the best answer. I could go crazy and say 8/3, but nobody says 8/3 of an hour. That's kind of weird. Again, if you want to use the decimal, that's fine, but don't round till the very, very end.
Can you just use the minutes and then move it to hours?
You mean converted all the minutes?
Yeah.
So if you converted it to minutes, so that'd be what, 120 plus 40, that's 160 minutes? So that's an easier conversion, I'll grant you that, but my rate is in kilometers per hour.
That's what I'm saying, like, can you move it to hours once you've done?
But you won't be done, you'll have to use 45 kilometers per hour and 60 kilometers per hour as part of the problem.
Okay.
I mean, you could change those to minutes, but that's more trouble than it's worth. So I like the idea, I like the thought, but all of your units have to be the same. So if you're going to change this to minutes, then you'd have to change this to kilometers per minute and kilometers per minute. Doable, but probably not worth it. Okay, so we got two parts of the trip. Let's just call them part A and part B. And I'm still thinking distance equals rate times time. Distance I don't know. That's what we're looking for. Rate is 45. And time I don't know. So that feels like that's not very helpful. Well, let's keep writing and see what else we learn. I think it's going to be the same thing for part B. Distance I don't know. Rate is 60. Time I don't know. Let's see. But what do we know? What's the total? What do we know of the total? Yeah, the distance is 150, and the time is the 2 2/3 or 8/3 or 2.67 or however you want to phrase that one. So let's see. I think the two distances will add up to one. Yeah, I don't like this one. The two distances will add up to 150, and the two times will add up to 2 2/3. Is there a better way to do this? Let's see. This is two equations and two unknowns. 45 times time A plus 60 times time B. That would be my total distance. That equals 150. That's good, I guess, but I have one equation and two unknowns, so that's not going to get me there yet. What else do I know? What do I know about those two times? The two times add up to 2 2/3. Oh man, that's a system of equations. They haven't done one of those in a long time. Let's see. Would you like to do substitution or would you like to do elimination? Do you remember those? Probably substitution, since you can solve for TA or TB pretty easily. So TA equals, I don't like 2 2/3. 8/3 feels weird, but we'll go with 8/3. So now I can plug this in for time A. Whoops. Yeah, that's time A. So 45 times 8/3 minus time B plus 60 times time B equals 150. Yuck, yuck, yuck. But now we're almost there. Like, we've got one equation with time B in it. Now this is solvable, especially with a calculator. (45 times 8/3). That's kind of nice. Fraction goes away. Yeah, now I'm just doing algebra 1. So 15 times time B equals 150 minus 120 is 30. Oh, they were kind to us here. Very kind to us. So time B is 2 hours, which means time A is 2/3 of an hour. Is that what the question asked? This is the annoying part of word problems. Right. So we found times, but it wanted to know how far. Well, we have an equation set up, so this won't be too bad. Distance A is 45 times time A. 2/3 of 45 is 30. And distance B, I can do 2 different ways. I know we went 150 total, so 150 minus 30 is 120. Or I know that we traveled 60 kilometers per hour for 2 hours. Either way, we get 120 kilometers. I'm just trying to think, was there an easier way to work that problem? If there is, I don't know. Let's do number 4. Back to upstream, downstream. This is the airplane flying into the wind, against the wind. Tim paddled his kayak 12 kilometers upstream. Upstream. 12 kilometers, so there's a distance. 12 kilometers upstream. Against a 3-kilometer current. And back again in 5 hours and 20 minutes. So that total time, here's our minutes again, it's messing with us here. 5 1/3 hours. How far could he have paddled in still water? Oh, well, that's not the question I wanted to answer. I want to know his rate, and then I can answer the still water question. Let's see. What's his rate in going upstream, fighting the current? 12 is the distance. 3 is the current.
It's unknown. Or it's minus 3.
We don't know minus 3. Yeah, we don't know minus 3. A good way to say it. And the time we don't know either, so we'll hold off on that. Downstream is 12. Right, because he's going to get out where he put in.
R plus 3.
R plus 3, because now he's got the current helping him. Again, we don't know the time. But what do we know about these 2 times? They add up to 5 1/3. So T1 is 12 over R minus 3. T2 is 12 over R plus 3. And those 2 times add up to 5 1/3. Again, 5 1/3, maybe that's weird. 16/3, also weird. 5.33, not quite accurate. So pick your poison on what number you want to use there. Now it's a rational equation. We multiply through, or may call it the denominators match, then get rid of the denominator. I'm going to pause and freeze and see if you can finish that one off. Is 16/3, because then you got the fraction thing. 12 over R minus 3 plus 12 over R plus 3 equals 16/3, and then we can get rid of all those denominators and not have to worry about the thirds anymore. How far did he travel total? How far did he paddle total? Total? 24. And part of that was with the current, part of it was against the current. He made it 24. If he was in still water, he could have gone a lot farther. And maybe that doesn't make sense intuitively. Like, it feels like, yeah, part of the time you're going with it, part of the time you're against it, it kind of works itself out. But no, he could have gone a lot farther in still water. The reason is, when he's fighting the current, it takes a lot longer. So he spent a whole lot more time fighting the current than going with the current. So, no current at all, he could have traveled a lot further. Okay. Why don't you try number 5? 5 is back to, I feel like we're jumping around types of problems here. An old conveyor belt takes 21 hours. By the way, today's assignment is 5 through 8. An old conveyor belt takes 21 hours to move 1 day's coal output from the mine to a rail line. Okay, who cares about the details? What type of problem is this?
Job.
Yeah, this is job equals rate times time. And you got an old one that can do it in 21 hours, a new one can do it in 15 hours. What if they work together? Why don't you see if you can set that one up? If there were 2 new machines, yeah, you can think of it this way. If there were 2 new machines working together, how long would it take? Yeah, but if there were 2 new machines, it would take 7.5. And if there were 2 old machines, it'd take 10.5. So I got 1 old and 1 new. It better be between 7.5 and 10.5, and it was. You don't have to do that, but I like to make sense of my answer so that if I get, 47 hours, hopefully my brain is turned on enough to think, wait a minute, it should definitely be less than 15 because they're working together. So keep your brain engaged while you're doing these, and you can catch mistakes, and then maybe go back and figure out what happened. 6. Okay, this is a different type of problem altogether. We're all over the place today. 2 positive numbers that differ by 8. 2 positive numbers. So I'm looking for x and y. Differ by 8? What's that mean? It means they have a difference of 8. True. How can I write that as an equation?
X minus 8.
There's a couple ways to do it. So I think I heard both. I would say x minus y equals 8. But you could say x minus 8 equals y. That would work too. Yeah, either one of those would work. But when I hear differ by 8, my brain thinks, all right, one of them minus the other gets me to 8. That's a great point. If I write it this way, I'm assuming that x is the bigger one. So you're right. If that's all you had, officially you should say absolute value, but I don't want to mess with absolute value in an equation. So let's just do x minus y, and we'll just say that x is the bigger one. Whose reciprocals, what's reciprocal mean? Careful, not the opposite. Opposite means change the sign, the flip. So be careful. Reciprocal is flip. Opposite is negative. So 1 over x and 1 over y differ by 1/6. Okay, but I need to be careful here, because if x is bigger, then which one of these is bigger? 1 over x or 1 over y? 1 over y is going to be the bigger one. Does that make sense?
Yes.
Yeah, if x is 1,000 and I flip it, I'm down to 1/1000th. So I need to kind of reverse my order here and go 1 over y minus 1 over x equals 1/6. And I don't think elimination is an option here. I think I have to do substitution. So you want to solve for y or solve for x? What's your preference? Because it doesn't matter. I think x, that would be easier. So x equals 8 plus y. So 8 plus y goes in for x. That's what it means. If x is 8 plus y, then I can replace x with 8 plus y. Dan, what do you know? We have another rational equation to solve. So this guy needs a 6 and an 8 plus y. This guy needs a 6 and a y. And the last one needs a y and an 8 plus y. All right, that's the junk it up step of the problem. But the next step is the best step. What are we doing next? Yeah, okay, we're getting lazy and just saying, canceling all the denominators. Fair enough. What allows us to cancel all the denominators?
OCD.
Yeah, we're going to multiply through by the OCD. But you're right, we've done this enough times that, we're just going to cancel all the denominators. 38 plus 6y minus 6y, that's nice. Although that makes me kind of nervous because now I lost my y's on that side of the problem. Equals 8y plus y squared. So y squared plus 8y minus 48 equals 0. Is that factor? Hope it factors. Otherwise I'm dealing with the quadratic formula. Y and y, 12 and 4, plus 12 minus 4. Find two positive numbers. So are those my two positive numbers? Negative 12 and 4? No. In fact,
would you be able to take the 0 equals and plug it into a calculator, hit table, and then see
Sure.
whichever one?
Yep. Be careful. Remember, that only works if your answers are on the table.
Gotcha. But it's an option.
It is an option. You could also find it on the, like, instead of the quadratic formula, like if you wanted to, I don't know what that is, but you could do the calc 0 and find it that way.
Okay.
Yeah, we've done that before. So which one of these is right?
4.
4, because it said positive. Perfect. X equals 8 plus y. So x is 12. So my two numbers are 4 and 12. 12 minus 4 is 8. I don't want to check the other one, but 1/4 minus 1/12 is, I guess, 1/6. Let's set up 7 and then we'll be done. Long day, but you're not going to have much homework, so at least there's that. The reciprocal of half a number. What the heck? Is increased by half the reciprocal of the number. Is 1/2. Find the number. Okay, so the number is going to be x. Okay, so the number is x. So what's half the number? Let's go piece by piece here. So x over 2. So half a number is x over 2. What's the reciprocal of x over 2? Yeah, 2 over x. Okay, so the reciprocal of half a number is 2 over x. That's a really weird way to say that. But we half it and flip it. Increased by, what's that mean? Added. So we're going to add half the reciprocal. Okay, well, what's the reciprocal of the number? X over 2. No, not the reciprocal of the number. Not x over 2, but 1 over x. What's half of 1 over x? 1 over 2x is, that means equals 1/2. So that is a weirdly worded problem, but I don't really think it's that hard of a problem to solve once you get to the bottom of this thing. And then your last one is another upstream, downstream problem. So we've done some of those. So, long day, a lot of work. Thanks for hanging with me. And you've got 1.5 problems for homework.
Wait, so that's something else.
Fair enough. That's not the answer. Now we need to solve for x.